Okay, so we are done with the windmills. We're moving on to our next source of renewable energy. You can see all of these boxes say H2. What is that? That's not water. Where's the hydrogen? Hydrogen gas. Okay? Now remember, certain elements, when they're by themselves, they always act in pairs. I think during the quiz we called them Brinkelhoffs. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. So when hydrogen is by itself, it's always paired. So basically this is hydrogen gas. What we're going to be doing is a similar unit where we're going to be creating cars that are powered by hydrogen gas. I have not yet tried these out. I will try them over the weekend. Hopefully we'll all figure out how to make these kits. And I think what we can do is similar to what we did with the wind turbines. We'll do a little bit of research. Maybe we'll form another debate, and that can kind of be our assessment again. I'll probably be making some more kind of guidelines for the debate, though, but I think it went well the first time.
Who won? Who won that?
The con side, which I think was your side, Ian.
We had many more points.
Well,
I thought the fourth side did.
Yeah! It's not guys!
Alright. What I want to do is start with this video.
What's it called?
Hydrogen fuel cells. So please watch the video.
It's gonna be, read this up. What's it gonna be about?
I don't know.
No, what's it about?
I usually sit around.
I know.
Oh, I'm sorry.
Fuel cells have the power to change our world. At Delaware, we are dedicated to making fuel cell technology a reality, to replace the internal combustion engine in your car with a clean, quiet, pollution-free fuel cell engine. Fuel cell-powered cars look just like other cars on the road today, but they are cleaner, quieter, more efficient, and work very differently. When you turn the key, hydrogen and compressed air flow to the fuel cell module, which contains the fuel cell stack. A fuel cell engine consists of the proton exchange membrane, or PEM, fuel cell module, coupled with the systems required in a typical automotive engine. The electricity produced by the fuel cell is delivered to the electric drive system in the vehicle. The drive system converts electrical power into the mechanical energy that drives the wheels of the car. The fuel cell generates electricity that can be used to power a car, truck, bus, or other vehicle for as long as fuel is supplied. The fuel cell is 2 to 3 times more efficient than your gasoline engine and does not create pollution. Additional benefits include increased performance and onboard power, higher reliability, and greater flexibility in vehicle design and engine layout. But how does the fuel cell work? A single PEM fuel cell is made up of 2 plates, 2 electrodes, and 2 thin layers of platinum-based catalyst, separated by a plastic membrane, which, when fed with the fuel, reacts electrochemically to create electricity. Hydrogen from an onboard storage tank and oxygen from air are fed through channels in the plates. Hydrogen flows on one side of the membrane, air on the other. The catalyst splits the hydrogen molecule into protons and electrons.
Okay, this is sort of the real important part right here. I want to make sure we're all clear on this. So basically, we have hydrogen gas flowing in. Now remember, hydrogen being a Brinkelhoff consists of 2 H's together. It hits this kind of membrane. PEM stands for proton, what was that E? We just saw it. Proton emitting membrane? It'll get to it in a second. But either way, the protons are allowed to pass through, but the electrons aren't. So here we have protons, which are pluses, and these are electrons, which are minus. Now watch the light bulb up here.
The protons can pass through the membrane. The electrons cannot, and have to pass through an external circuit, creating useful electricity.
Okay? Now let's think back. What, in the most fundamental way, what is electricity? Moving electrons, or it's the flow of electrons. So right here, when we have 2 hydrogens moving, there's no electricity because the 2 hydrogens are locked in place. But once they split Actually, I kind of paused it perfectly. You can see the hydrogens are splitting into pluses and minuses, protons and electrons. The protons pass through the membrane. The electrons have to go around the membrane. By traveling around the membrane, we have electrons all moving in one direction, generating electricity. Now here it's showing a light bulb, but what we're going to see is that electricity is what's going to power the car. And obviously you can't do it with one of these. In a car battery, you have like thousands of these all lined up.
On the oxygen side of the membrane, the protons and the electrons react with oxygen from the air in the presence of a second catalyst layer, generating water and heat. By stacking together single cells, like slices in a loaf of bread, you make a fuel cell stack to produce the required amount of power. Just like your car, fuel cells need fuel to operate. The Ballard fuel cell uses hydrogen as a fuel, which can be produced in many different ways. And once produced, can be stored as a compressed gas or liquid.
Does this look familiar? Hopefully. We did a lab with this. Basically, when you run an electric current through water, it splits up the water into two tubes. One of them will have hydrogen, one of them will have oxygen. Remember, we looked at the levels. Which tube do you expect to have more gas in it? Hydrogen, because it's H2O. There's two hydrogens for every oxygen. So this is one way that hydrogen is produced.
Or in a chemical or metal compound. Different areas of the world will create hydrogen in different ways, depending on economics and available resources. Hydrogen can be delivered to fueling stations by road, barge, rail, or pipeline, or can be made on-site at gas stations. People may one day be able to produce their own hydrogen at home. You can see there are many options available to enable the hydrogen infrastructure to grow. Fueling the vehicle is very similar to the way you refuel your vehicle today, but required.
I suppose I should make this startup noise.
No, the speaker died.
Right. It only takes a few minutes to refuel a fuel cell car. And when fueled by hydrogen, a fuel cell emits water and heat, and no pollution. Think what this means to the air around us.
I suppose I should make this startup noise.
Yes, we're having speaker malfunctions here, so I might have to go without it. But basically, let's take a look at this image, which I love. Fuel cell cars. No emissions, no noise, no vibration, increased performance and onboard power, higher reliability, greater design flexibility. Do you think this video is a little, maybe one-sided? Yeah. Now, I'm not saying this is a bad idea. I'm just saying when I see a video with 6 awesome things, I'm a little skeptical, okay? So what we're going to be doing is make sure we do like a thorough analysis of hydrogen fuel cell cars. Because if this were true, if there were no downsides, why would anyone be driving a gasoline car? You know? So let's look at, well, actually, I'll pause from this and I'll just go over the mechanics again. Because I want to make sure we're all clear on this. So if you guys could just take out some notes and kind of sketch this. I want to make sure we all know what's actually going on inside the car.
I think, yeah, today's super.
Proton exchange membrane, all right. Okay. So the key to a hydrogen fuel cell car is this. Let me orient my board here.
It's like that, you know? It is that.
Okay. All right, let's see if that worked. PEM, which is a proton exchange membrane. This is really the key to a hydrogen-powered car. Now on either side we have these two sort of catalysts, we'll call them. The role of these, it's different materials. It's designed to basically split the hydrogen atom up. Okay? And again, before we even go any more in depth, let's make sure we're clear on what the hydrogen atom actually looks like. So hydrogen, if you want to look at what it looks like on the periodic table, it's going to be atomic number 1, and the molar mass is 1.00794. Okay? So, in a hydrogen atom, how many protons do I have? 1, thank you. Atomic number 1, so we have 1 proton in the nucleus. Now this number shows the average atomic weight of, or I should say the atomic weight of the average hydrogen atom. And 1 proton and 1 neutron each have an atomic mass of what? 1 AMU. So therefore, based on this, how many neutrons does the average hydrogen have? 0. Because this 1 is the proton. Every single hydrogen has to have 1 proton. But because it's pretty much 1, it means that most hydrogens have 0 neutrons. Some hydrogens have more than 1. So, well, I should say some hydrogens have 1 neutron. Other hydrogens have 2 neutrons. And in fact, those, what we call heavy hydrogens, those are responsible for nuclear fusion. Because you need like kind of heavy isotopes of that. So anyway, most hydrogen looks like this with 1 proton. And how many electrons would this have? Just 1. So we can draw our E minus. And that's going to be orbiting the nucleus like this. Okay? So that's our hydrogen atom. It's 1 proton and 1 electron. Okay? So in our fuel cell, the hydrogen atom, which is really H2 because they don't act independently. So we have a proton with an electron. We have a proton with an electron. They travel towards this. It hits this boundary, which because of the type of metal, it's going to split it up. So now we have 2 electrons and 2 protons split up. Which way do the protons move? Do they go around or do they go through? They go through. Proton exchange membrane means protons can pass through. So these protons are just going to pass right through. But the electrons are forced to go around. Okay, so we can go either way. Let's just show it this way. So the electrons have to go around, E minus. The other one, minus. And it's this movement of electrons down here or up here movement of electrons is what actually generates the electricity. So in order to keep this going, first you need fuel to come in. Fuel is in the form of hydrogen. And you need something to carry these out. Because if you just generated all these ions in the end, it would basically fill up and, the cycle wouldn't continue. So what you need is air to flow in like this. Now, what is most of air made of? Which gas? Nitrogen. A lot of people think it's oxygen. Air is about 79% nitrogen. And because nitrogen is a Brinkelhoff, we write N2. And it's about, I think it's actually 78%. 21% of air is what? Oxygen, which is another Brinkelhoff. And the last 1% is a mixture. Water vapor, CO2, argon gas, a lot of different things. The important thing here is the O2. Okay, so in the air we have O2, which is going to split up because it passes through another membrane. O2 becomes oxygen plus oxygen. And the oxygens are going to pick up these pluses and these minuses. Because remember, one proton plus one electron is what atom? Or what element, I should say. One proton, one electron. Hydrogen. So basically, the hydrogens split up, pass through, and then reform, and they're going to stick to this oxygen. Okay? So what's leaving here is an oxygen that now has two hydrogens stuck back onto it, which is what? Water. Okay? Another sort of ingenious process here is that it takes hydrogen and it produces H2O or water. So kind of one of the things they like to market it is you can take a glass, put it next to the fuel pipe, let it drip in, and then drink it. Now, I would never suggest they actually do that, but they're saying theoretically you could. Obviously, there's going to be things, metals mixed into it, so you wouldn't want to do that. But basically, we have hydrogen splitting into protons and neutrons. Protons pass through, electrons move around, create electricity, and we form water. Okay? Seems like the perfect idea, right? One problem with this, and I'm not trying to skew the debate, not a problem. One issue that we have to overcome is where do we get our hydrogen from? Basically, in a car, you need to get a hydrogen tank and put it in the car, and that supplies your fuel. You drive until that tank runs out of hydrogen, you have to buy another hydrogen tank and put it in. Well, it's not really a tank. I should change that. You go to a special gas station, and you plug it into your car like I showed at the end of the video, and it just pumps hydrogen into your car. But either way, we need to gather hydrogen gas to put it in the cars. So let's talk about where hydrogen comes from. I should say H2. Okay. Now really, if I want to go with the most fundamental answer, where hydrogen comes from, well, that's just the Big Bang. About 90% of matter in the universe is hydrogen atoms floating around. But here on Earth, you're not really going to find H2 floating around in the air. It's there, there's tiny bits of it, but what do we know? What's one property of hydrogen gas? Chemical property, is it flammable? It's flammable and it's very reactive. So if you have hydrogen gas floating around in the air, something's going to, not really ignite it, but it's something going to react with it. It's going to find oxygen and form water. So H2 is not just floating around in air. So one way we produce this is called electrolysis. Electrolysis, which we've done before. You take salt water. Needs to be salt water. It doesn't have to be NaCl. It has to be any kind of salt. And you need some kind of ions floating around because regular water doesn't conduct a current, but salt water does. Take two tubes. You run an electric current. And the gases collect. Basically, electricity splits water up into hydrogen and oxygen gases. And the way you make sure it goes in the right tube is you put little pieces of metal here. One of them is going to be nickel, and the other is probably going to be zinc, I believe. Don't quote me on that. But basically, we get H2 gas in one, O2 gas in the other. Do this on a large enough scale, you'll collect hydrogen, enough hydrogen to put inside a tank. Okay. This, however, is pretty inefficient. I think the stat, I believe it's less than 5% of industrial hydrogen is produced this way. The vast majority of hydrogen gas is produced a different way. It's important to note this because we actually did this in class. And I think with these kits, part of the kit is this little gas station you get. And I think this is electrolysis. I believe it creates H2 using this process. But I will find out for sure this weekend when I put it together. The other way, and the most important way, let me make sure I have the right term for it. Steam reforming. Steam reforming. What you do is you take CH4, which by its proper name would be carbon tetrahydride, but this is commonly called what? Methane or natural gas. Well, natural gas is really a mixture of gases, but it's mostly methane. You take methane, you add water at 700 to 1100 degrees Celsius, which is like 1500 Fahrenheit. So obviously what state of matter is that water in? Vapor, it's gas. Okay? If you get it hot enough, what will happen is the methane will strip the oxygen off of this, and you will get CO plus H2. What is CO? Carbon monoxide plus hydrogen gas. And when we balance this, let's check our, I would suggest hydrogens first. So H4 and H2. So what number do I need in front of the H2 here? A 3. All right, 4 hydrogens plus another 2 gives me 6. 6 hydrogens. Let's now check our carbons. 1 carbon, oxygen, 1 and 1. So this is now balanced. So this seems pretty good. For every molecule of methane, we produce 3 molecules of hydrogen gas. What are some, sorry, before I even get into that, we're left with carbon monoxide and hydrogen gas. But we can actually generate more using just this. So what they do is they then cool it down. And I'm going to do this in blue to show it's colder, but this is still 300 degrees Celsius, which is still like 500 degrees. The second step, they take the carbon monoxide and they react this with water, and we get CO2 plus H2. And this one is actually already balanced. Now I see 2 kind of problems with this. Not really problems, but two reasons that hydrogen cars might not be this miracle cure for everything. First of all, what's our end product besides hydrogen?
Carbon monoxide.
And down here,
Carbon dioxide.
carbon monoxide and carbon dioxide. And in fact, most of that CO gets converted into CO2. So really, these are the 2 main waste products. Well, that's not really waste, that's what you're trying to make. So this is our waste. So when we say hydrogen fuel cell cars have no emissions, that's true. No CO2 is produced in the car, but CO2 is produced to create the hydrogen. That's one important thing to note. Okay? Now, I will say, in defense of this industry, this is a lot cleaner than oil, coal, natural gas, but it does produce CO2. It's not a completely carbon-free process. Does anyone see another reason this is going to be a very difficult thing to achieve? Like, what's a big challenge we have to do for this process? What do we have to maintain? Glenn? Right. We have to maintain a temperature of 700 to 1100 degrees Celsius. How do you think we maintain that temperature? Energy, or in other words, we burn stuff. We burn things to keep 1000 degrees Celsius reaction going. What types of things do we burn? fuel, coal, natural gas, oil. I'm not sure what they exactly use here. I would imagine they burn methane because they have methane available. But basically, you need to burn these products or these fuels in order to create this heat. And thinking back to our combustion reaction, it's a hydrocarbon, for example, CH4. What does this need to react with in order to burn? Nope. What gas in the air? Oxygen. What does it create? Two things. Energy plus what else? Come on, this wasn't too long ago. H2O and CO2. So again, we see more CO2 being produced from this. Okay? I'm not trying to skew you guys in one way or the other. I'm just trying to say when I see a video that shows 6 benefits of hydrogen power, you need to look more into it. Hydrogen does not grow on trees. We produce it in giant factories, and there are downsides to producing it. Okay? Let's talk a little bit more about... I had another video, but my sound isn't really working well. So what I'll do is sort of introduce the kits that we're going to be using. So we're at 15 minutes. Let me stop this.